So in this video we're going to be required to explain the characteristics of a quadratic function. This is right off the state standard. We're going to investigate and explain characteristics of a quadratic function. And the first one we're going to look at is the domain. Alright, so what is a domain? Domain is simply the possible x values. And one thing that we have to pay attention to is that we've got to realize that this thing, or this quadratic function, it's got arrows at the top. Now the arrows mean that it continues upward, but it also means that it continues both to negative infinity on the x-axis and positive infinity. So where I'm going with that is that your domain, that's your possible x values. For this particular function, any x value is good. So that means that our possible x values would be anything from negative infinity to positive infinity. Now, we got to look at what our range is. Now, range, that's the possible y values. Looking at this graph has nothing below this point. There's nothing down in here anywhere. No graph. So really what we're saying is that the graph doesn't exist below this point. So we have to come up with what is this point? Well, if this is 0 at our x-axis, this is going to be -1. This is -2, -3, -4. So our y value is -4. So my domain is going to be any y's greater than or equal to -4. So I'm saying anything from here up, my graph exists. Okay, so I've got my domain done, I've got my range done. Vertex. I got to identify where's the vertex. Well, that's this point right here, which we've already said the y-coordinate was -4, but what's the x-coordinate? Well, if I'm at 5 here, and this is going to be 6, so my point is 6, -4. So my vertex is at 6, -4. Next thing, axis of symmetry. Where is it? Oh. What's really nice about the axis of symmetry is that it is always going to be aligned with your vertex. And so this line here is the line x equals 6 because any point on this line has the value of x equals 6. So my axis of symmetry is x equals 6. Alright, I'm going to switch back to black. What's next? Zeros. Zeros of the function are where the graph crosses the x-axis. So I have a 0 here, and I have a 0 here. So this one is 4, 0, and this one is 6, 7, 8, 8, 0. So my zeros are at 4, 0, and 8, 0. Now I want to know intercepts. Okay, that's a couple of two different types of intercepts. We have x-intercepts, and we have a y-intercept. So my x-intercepts are going to be my zeros of the function are 4, 0, and 8, 0. And my y-intercept, well, in this graph it's really hard to tell because I didn't capture the whole graph. So let me go back over to the calculator I was using, and let's look at this entire graph. The function is x minus 6 squared minus 4, And if we were to scroll up, we can keep seeing where's the y-intercept. And my y-intercept is going to be at this point right about here, which is somewhere close to y equals 32. So let me go back to my graph here, and I would say 0, 32, because let's look at it again. At 0, 31, really close to 32. And let's just say that's about it. And what else do we have? Let me go back. That was our axis of symmetry, zeros, intercepts, extrema. Okay, that's what's next, extrema. That means what is either the highest point of the graph or the lowest point of the graph. Since the graph extends to infinity, there is no maximum point, but there is a minimum point at the vertex. So as far as extrema goes, we have a minimum at 6, -4, and we have no maximum. And the next thing to look at is our intervals of increase and decrease. Okay, so intervals of increase and decrease. I'm going to erase some of this just to clean up the graph a little bit. You read these from left to right. So see that my graph is going up from the vertex as I move along the x-axis. My graph continues to increase in value. So that means that my interval of increase, or my IOI, is from 6 to infinity. And again, I read that along the x-axis. I start going up at 6, and I keep going up to infinity as I go along the x-axis. And that being said, again, on the x-axis, I'm looking for my interval of decrease. Well, it starts going down way back here at negative infinity until it gets to the vertex, at which point it starts going up. So my interval of decrease is going to be from negative infinity to 6. And then rates of change. All right, how do we work with rates of change? Well, what we want to do is we want to calculate the average rate of change between two particular points. So let's say, for instance, that on this graph we have, I don't know, we want to find the rate of change from this point to, let's find one on the graph, to this point. And we want to know what's approximately, or what's the rate of change. All we're doing is going to calculate what's the slope between these 2 points. And if you remember, the slope formula is m equals y2 minus y1 over x2 minus x1. So let's call this point 5, -1, 2, 3. And let's say that this point is 9, 1, 2, 3, 4, 5. We just want to calculate the slope between these points. So the slope is going to be 5 minus -3 over 9 minus 5. So that gives me, two negatives make a positive, so 5 plus 3 over 9 minus 5. So I have m equals 5 plus, oh, that's not, oh, I did that wrong, didn't I? 5 plus 3 is 8. I hate it when I do that. 5 plus 3 is 8 over 9 minus 5, which is 4. So that means that my slope is 2. So my average rate of change between these 2 points, here and here, the rate of change between the defined points, 5, -3, and 9, 5 equals 2. And that's analyzing a graph.